All right. So OpenFlow is currently the hot topics in networking. Very hot topic. And so we'll talk about 6 different things. Planes of networking. Then we'll talk about OpenFlow. How does it operate? Who implements them? How it has evolved? And what are its limitations? Oftentimes when people talk about OpenFlow, they talk about SDN and NFV. I'm not going to talk about them in this module. They will be talked about in later modules. So this is plain OpenFlow. Now, OpenFlow 1.0 was a big success. It was implemented by a lot of companies. And I have put a list here, not that you have to remember this list. You don't have to memorize it, or I won't ask you whether HP implemented it or not. But I'm just trying to tell you that HP and all the companies' name you are there are here. I mean, Extreme, Brocade, IBM, Juniper, NEC, Netgear, Pronto, and so on and so forth. So all of these people implemented. Basically, I think most of these people implemented using what they call merchant silicon. Merchant silicon is not listed here for some reason. Anyway, Broadcom makes the chips. So that is called merchant silicon. So Broadcom chips, were used in many of these. In addition, there are many software-based implementation. So these are the names of the software-based implementations. And these you might want to remember a little bit. I will tell you why. Because these are the ones that you will be using. If you ever did anything with the OpenFlow, you will need to get this software, download it, and which you will be doing, by the way, in this course. And so you have to download it, install it, and all that. So these are all software pieces. So software switches, Indigo. And by the way, all the references are in the bottom for all of these. So, you can find more about them. Indigo, and you can download the full slides from the website, not today, but some other day, and then you can click on them. Indigo is an open source implementation which runs on the physical switches. So this is actually more like a firmware, not software. Firmware, which runs on the physical switches and uses features of the ASIC to run OpenFlow. So you just download it. If it is supporting your hardware, then it will you have OpenFlow switch. Link is another open source implementation that runs on Linux, Solaris, and then Windows, Mac OS, and FreeBSD. Then there is Panto. I don't know how to pronounce that, Panto, but anyway, it turns a commercial wireless router access point into an OpenFlow enabled switch. OpenFlow runs OpenWRT, which is actually some kind of wireless module or package, and it supports generic Broadcom and some models of Linksys and TCP link access points with Broadcom and Ethernet. So there are some products from these two companies that can use this particular thing instead of Indigo, and they can become OpenFlow switch. OF13 soft switch. OF, by the way, is OpenFlow. So OF13 soft switch, this is a user space software switch based upon Ericsson Traffic Lab 1.1 soft switch. So let me see what is user space. Everybody understands what is user space? Is that if you have a Linux machine, you cannot really change the kernel. But you can run any program you want. So this program will run because this is user space program. Okay? And you can make a soft switch on your laptop or your computer. XOR Plus. This is an open source switching software to drive high performance ASICs. So now again, this is like a firmware. Okay? And this supports a lot of stuff. STP is that spanning tree protocol. RSTP is rapid. MSTP is multi-spanning tree. LCAP is what? What is LCAP? I don't remember now. QoS, quality of service. VLAN. LLDP is the link discovery protocol. ACL is access control list. OSPF is whatever OSPF. ECMP, RIP is the routing information protocol. IGMP, IPv6. And PIM is the protocol. This is the multicasting protocol. So all of these are supported in the XOR Plus. And then finally, there is one thing that you will have to remember, and that is Open vSwitch. So I have a whole slide on Open vSwitch. Before I go to Open vSwitch, Any question about these? Many of these are basically firmware, some of them are software. You may not really need this, but just, basically just for the sake of completeness, you have to know that there are many switches, and when you need it, you might just want to come back and check this out here. But open vSwitch. This is a switch that you will use. This is a switch which is used everywhere. So open source virtual switch. Open vSwitch is open source virtual switch designed by Nicira first, I think. And then it can run as a standalone hypervisor switch. So remember, in our diagrams we showed in VMware diagrams, hypervisors, you have this vSwitch. Now that is VMware switch. But this is an open vSwitch. This is open source. You can run it in their hypervisor. You can run it in anybody's hypervisor. So this is what everybody actually runs. All right. So this runs in Zen server. It runs on Jet Cloud Platform. It runs on Proxim, VE, VirtualBox, Ken, Zen, KVM. So this is used. This is a default switch in all of these places. This is integrated into OpenStack. Now, what is OpenStack? OpenStack is basically the cloud management system. So when some company has a cloud, they will need one of the cloud management systems, and these are all the list here. OpenStack, OpenQRM, OpenNebula, OVERT. These are all the cloud management systems. These are the ones that you use to tell that I want so many VMs, and those should be on these physical machines, and they should be connected like that. All of them use Open vSwitch. It is distributed with Ubuntu, Debian, Fedora, Linux, everything else. So this is it. This is the switch. All right, and it operates. It follows the OpenFlow. Also, of course, Open vSwitch doesn't have to be OpenFlow. Open vSwitch can run as a normal Ethernet switch without any OpenFlow, but it also implements OpenFlow. Well, in addition to OpenFlow, it implements many other things, and so basically, first of all, it implements monitoring. This is the key, monitoring, and there are many monitoring protocols, starting with NetFlow from Cisco. This is NetFlow is a protocol for sampling and collecting traffic statistics. Once Cisco came up with the NetFlow, then every other company has its own. So there is a SFlow, which is from sflow.org. There is a JFlow from Juniper. There is NetStream from Huawei. Then after all these were done, then IETF has its own standard called IPFix. IPFix is IP Flow Information Export Protocol, which is the IETF standard for NetFlow. SPAN and RSPAN are similar things. Remote Switch Port Analyzer, which allows port mirroring. What is port mirroring? Well, anyway, let me first read this whole thing. Port mirroring by sending a copy of all packets to a monitor port. That's what port mirroring is. Is that what you want to do is, suppose you have a 32 port switch and you want to monitor everything. Okay? You could program the switch so that everything that is going in any direction is sent to you on port number 13, whatever port number you want. That is called port mirroring. Everything going in port 1 goes to port 13. Everything going to port 2 goes to port 13. You don't have to have all ports go to port 13. You could just go 5 ports I want to monitor. So that is called port mirroring. Okay? When a packet comes, 2 copies will be made. One will be sent to where it is going. One will be sent to you. Why you want that? Yeah. Okay. He says that NSA needs it. But in addition to NSA, we also need it. If you are a network manager, you really want to see what's going on. And WashU has its own IDS, intrusion detection systems. So they monitor everything that you send out, by the way, believe it or not. Okay? So that is why you need this. RSPAN and NSPAN. Now, GRE tunneled mirrors. And this is another way of mirroring, which is monitoring device is remotely connected to the switch by a GRE tunnel. So you don't have to be local. You could have a GRE tunnel to that port. And everything that is sent, basically GRE means you could encrypt it and send it over so nobody else can see what you're seeing, and so on. So all of these protocols are for monitoring. And all of these are supported in that switch. I had never heard of many of these, before. So I had to go through each one of them. Believe it or not, actually I did not put the URLs. I should probably put the URLs, but I have gone through the original sources for each of these protocols, and then we had to figure it out what they do. Then the list doesn't stop there. It does link aggregation like a real switch. It does VLANs like a real switch. It does connectivity fault management. It does bidirectional forwarding detection to detect the link faults. So basically it checks out if some link goes down. It does spanning tree protocol. It does policing. It does OpenFlow. It does multi-table forwarding pipeline, which is actually part of OpenFlow. We'll show you in a minute. It does IPv6. It does GRE, VLAN, VXLAN. IPv6 means it can read the IPv6 headers and figure out what to do with them. GRE, VXLAN, and IPsec tunneling. And it implements these things. So it implements VXLAN. Okay? So if you wanted to set up a tunnel, all the things that we talked about a minute ago, it can do that for you. And it has a kernel and user space forwarding engine options. So you could run it in the kernel or you could run it in your space. It's a very powerful piece of code. And that's why it is a very popular piece of code. To manage the vSwitch, you need a protocol, and that protocol is called OpenVSwitch Database Management Protocol, OVSDB. By the way, OpenVSwitch, a lot of time people don't write the whole thing, they write OVS. OVS means OpenVSwitch. So OVS Database Management Protocol is OVSDB. Basically, this is your OpenVSwitch. It will have three modules inside it. One is what is called OVSDB server. There is what is called vSwitch daemon. So it is switch D. And then there is a forwarding path. So this server talks to this control and management cluster, and the protocol that is spoken between them is called OVSDB. Why is it called database? Because this database has many things, including how many packets were seen, how many packets were done, this and that, whatever, everything is stored in tables, and those tables can be queried by this database thing. And this protocol could be OpenFlow. This OpenFlow protocol is simply the forwarding part of it. And that will basically program this thing here. So you have to understand the difference between OVSDB and OpenFlow. They are not competing. OpenFlow is programming the control part. OVSDB is querying the rest of it. So anyway, OVSDB, monitoring capability using publish subscribe mechanisms. So there could be lots of clusters like this. There may be two people who are monitoring this switch. Alright? So there could both be subscriber to this publisher. Then it uses JSON, JavaScript object notation, for a schema format. Every database has a schema. So in this case, that is the one. And RPC for the JSON RPC over TCP for wire protocol, this protocol here. And the schema could be like this. This is just an example of a schema. Some names, some versions, some tables, and so on and so forth. And then anyway, RPC methods could be list, could be get, could be update, could be lock, and so on and so forth. So there are some methods defined. And OpenVSwitch project includes open source OVSDB client as well and server implementation. So when you download the OVS code, you will find the server, everything else built in for you, standard. It's really interesting to me. And Bruce Davey is the author of this OpenVSwitch as well as he was part of the STT. He is from Nicera. So I think this is, I find it a really good contribution to the world. Okay, so the question is control and management cluster is a controller? Yes. Yeah, so here it is. It is a cluster. Means it could be many of the controllers. Cluster is more than one, right? Cluster means in a group. And so it could be more than one controller, and it could be different than OpenFlow controller too. Because there could be a controller which is not interested in OpenFlow but just interested in the data here. and they would be speaking OVSDB. As shown in this picture, only one cut cluster is talking both protocols. It's not necessary really. There could be different pieces. Yeah, right. So it's really interesting. The server is inside the switch and the client is outside, because the server is giving the data. Right? Client is asking for the data. So you want to ask, how many packages did you get? That is the client's question, right? The server will give you the answer. That's why it is called server, right? It could have been other way around, by the way. I mean, this is other way around in SNMP. In SNMP, the thing which is inside is called SNMP agent, which answers your questions. It's not called SNMP server. It's called agent. Here, instead of calling OVSDB agent, they call it OVSDB server. Okay? All right, I think we'll stop right there.